There we go. So schedule for the week. We are going to today cover 5.1, which deals with rational exponents and radicals. And then at the end of the week, Thursday, Friday, we'll be graphing radical functions. And then just a reminder, chapter 9 work, get that done as soon as possible. The last day to submit any work is June 10th. And I'm not sure if that deadline is 3:20 or if it's open till midnight, to be 100% truthful. So get any work turned in that you can before the deadline. All right. So 5.1 on page 7 in your pink packet, if you have it. Simplifying expressions including zero and negative exponents. Also relate roots and rational exponents and use them to simplify expressions. That's what we're going to do today. And it's actually, I think, a lot easier than maybe it sounds. So let's get started. So similar to last Thursday and Friday, we're just going to start with, hey, we have this expression that we're used to seeing. 2 cubed is 2 times 2 times 2. And every 2 that cancels with, that appears in the numerator cancels with 1 that appears in the denominator. And when you cancel everything out, your answer is 1. Right? Because if you think about this, 2 to the third power is 8. 8 divided by 8 is 1. If we use our quotient of powers rule, where we subtract exponents, as an expression with an exponent, 2 to the third divided by 2 to the third is 2 to the 0 power. And so any number or variable raised to the power of 0 is 1. There is one exception. 0 to the 0 power is not 1. That is undefined. But that won't appear in any of our work. So a to the 0 power is equal to 1. All right, so a couple of examples. 5 to the 0 power, that's going to equal 1. One that's a little maybe less understood, negative 113 to the 0 power. What this was really saying is we have negative 1 times 113 to the 0 power. So this is negative 1 times 1. If it's not in parentheses, that negative does not get grouped with the exponent. It's kind of important to remember. 2x over 7y cubed, all raised to the 0 power, is 1, and we're going to multiply that by 4. So here we get an answer of 4. For the try now, what's the answer? What is this equal to? Go ahead and just unmute and shout it out, or type it into the chat. But this is hopefully a pretty straightforward question.
I think it's 1.
I think it's 1. I agree with that. Excellent. All right. Negative exponents. So negative exponents are a little bit different. Here we can use the 0 power rule. So this would be 2 to the 0 power is 1 over 2 to the 3rd. If we use the quotient of powers, we would take 2 to the 0 minus 3, which would be 2 to the negative 3rd. Okay. So if I had 2 to the 0 divided by 2 to the 3rd, I could combine those. I could say, well, that's the same as 1 over 2 cubed, or 2 to the negative 3rd. And what that means is 2 to the negative 3rd is the reciprocal of 2 to the 3rd. So whenever we have a negative exponent, we can make it positive by writing 1 over that base to that power as a positive value. Okay. A couple ways to think about it. This negative, you can think, well, that means I'm in the wrong place in a fraction. So if it's in the numerator, which if we just have a number, a base to a negative exponent, that's considered the numerator. We put it in the denominator to make it positive. If it was in the denominator, it would go to the numerator and become positive. All right, so, and it just changes the exponent. So 3 to the negative second would be the same as 1 over 3 squared. And 3 squared is 9, so 1/9. Here, our denominator is to a negative exponent, so it says, hey, take this thing that's in the denominator, move it up into the numerator. So this will be 1 times 4 squared, which is 1 times 16, which is just 16. Negative 6 to the negative second. Remember, the negative is not part of the thing to the negative second power. Just the 6 is taken to the negative second power. So this would be the same as negative 1 over 6 squared. And again, 6 squared is 36. All right. So what I'm going to do is allow you just take a minute or two and try these. All right, so for this one, the negative 3 doesn't have a negative exponent, so it's going to be in the numerator. X to the 5th has a positive exponent. It's going to stay where it is. Y has a negative exponent. To make it positive, we move it from the numerator to the denominator. And the Z has a positive exponent. It stays where it is. There is our expression written with only positive exponents. So that's kind of the first part of our lesson today. Now we're going to look at the second part, writing radicals with exponents, and it's kind of simplifying some radicals. So some terminology. A lot of times in square roots, we don't write it, but this tells me what root I'm going to take. So if it's a square root, it would be 2, but again, normally we don't write it there. The thing underneath the radical is called the radicand. Okay. So one way to think about it is kind of working backward. We could think what number to the nth power equals a, or written this way, it's the nth root of a is what value, okay? And so again, rather than writing things like the second root of some value, we just write it without an index. So some examples here, the square root of 49, because it's not positive or negative, it's just going to be 7. The cube root of 27 is 3. So what these mean, this means 7 squared is 49. This means 3 to the 3rd power is 27. And The fourth root of 16 is 2, so 2 to the fourth power would equal 16. Most calculators can do multiple roots. It's just pretty difficult um, to set it up. All right, so one thing that might be helpful is this chart. All right, so filling out this chart, what this says is like this first box, we would have 2 squared, that's 4. And then 2 cubed, 2 times 2 times 2 is 8. So what we're doing as we move to the left in this first row is we are multiplying by 2. So 2 to the fourth power would be 16 because 8 times 2 is 16. 2 to the fifth power is 32. And 2 to the sixth power is 64. 3 squared is 9. And then if I multiply by 3, I don't want to put it on the bottom, sorry. That would give me 27. 3 to the third power is 27. Multiply by 3 again. 3 to the fourth power is 81. 3 to the fifth power is 243. 4 squared is 16. Multiply by 4 to get 4 to the third, which is 64. Multiply by 4 to get 4 to the fourth power, which is 256. And this is just multiply by 4. 5 squared is 25. Multiplying by 5, I get 125. For 5 to the third, and 5 to the fourth is 625. 6 squared is 36. If I multiply by 6, 6 cubed is 216. 7 squared is 49. Times 7 is 343. 8 squared is 64. If I multiply 8 cubed would be 512. 9 squared is 81. 9 cubed is 729. And the tens are my favorite because they're pretty easy. 10 squared is 100. 10 cubed is 1,000. Okay. So a way that you can use this chart, if I was asked, hey, find the cube root of 343, what you would do is you would find 340. You go in the cube column. Here's your index. Find 343. It's right here. So your answer is the base 7. Or if we wanted the fifth root of 32, go to the fifth root, find 32. our base is our answer, in this case, 2. All right, so how is this going to help with radicals and other things? When we have a radical expression, like the b for our index, a for our exponent, b cannot be 0. We can write this as x to a power. So x is to the a divided by b power. So x to the a over b a is the exponent, b is the index, if we write it in what's called radical form. So x to the a over b would be the b root of x to the power of a. And it works both ways. We could start with the radical form, b, the b root of x to the a, and write it in exponential form. Goes either way. All right. So converting to radical form. The 3 becomes our index. The 2 is the exponent. And we're going to write the exponent underneath the radical symbol. 7 to the 3/5. The 5 is our index. The 3 is our exponent. 7 is the base that goes as is the base still under the radical. 5 to the 7/5. Here, 5 is our index. So index, exponent. And one thing that I haven't talked about yet is reducing. So if you look at x to the 2/4, I don't want to write it. Do not write this as the 4th root of x squared. Instead, let's reduce that fraction first. 2 divides into both. So we get 1/2. So this would be the square root of x to the 1st. Or just the square root of x. And remember, we don't need to put that index of 2 there. All right, here's another one to try. First thing we're going to do, reduce. So this is the same as b to the 3/4. Now we get 4th root of b cubed. 4 goes as the index, 3 goes as the exponent. All right. So convert the following to exponential form. So remember, if we have this, the root symbol, the radical symbol, that's radical form. Exponential form, we just have it with an exponent. So we're going to get 3. Our base is always going to be the base. The exponent goes in the numerator. And the index goes as the denominator. So I'm going to rewrite it so it's not quite as busy there. 3 to the 2/5 would be in exponential form. Seven to the 3/4. Base stays as 7. The exponent goes in the numerator. The index goes in the denominator. Here's a tricky one, maybe. A to the 4 over. When there's no index, it's like there's a 2 there. And 4 over 2 is the same as 2. So we do want to reduce whenever we can with those powers. And the last one, x to the 3 over 7. All right. Another one to try. All right, so for this one, I'm going to write it. The 4 goes in the numerator, the 6 goes in the denominator, and don't forget to reduce. There's a factor of 2 that divides out evenly to give us 2/3. All right. So now what we're going to do is we're going to use the chart and properties of rational exponents to evaluate the following without using a calculator. So 125 to the 2/3 power, that's the same as the cube root of 125 squared. So what I would do is do the root part first. So cube root of 125 means that I would get 5. Okay, so one of the things that might be helpful, you can move that power out and take everything to that power, which for these problems, I would do that. So we said the cube root of 125 is 5. And then we can use the chart, or hopefully we know this already, but then 5 squared would be 25. So 125 to the 2/3 power is 25. 8 to the negative 4/3 means we have 1 over the cube root of 8 to the 4th power. So this would be 1 over 8 to the 4/3. So again, if I look in my cube roots, there's 8. The cube root of 8 is 2. And then if I go back up, 2 to the 4th power is 16. So the 16 is what's in the denominator. A couple more. So here we would have the 5th root of 32 cubed. So 5th root of 32. So 5th root, that's across the top of 32, is 2. 2 cubed, again, if I look at the table, is 8. (36 to the negative 3/2). So again, remember that negative means it's 1 over 36 to the positive 3/2. So 1 over the square root of 36 cubed. So I look at the square root of 36. That is 6. And then I'm going to cube 6. 6 cubed is 216. Try this one. 256 to the negative 1/4. So if you have your chart, that will. All right, so here's how we can get this one. So this is 1 over 256 to the positive 1/4, which is 1 over the 4th root of 256 to the 1st power. Now, normally we don't worry about that 1st power because it's pretty easy to calculate that. But if we go to our 4th power column, 256, there's our base, 4. So this is 1 over 4 to the 1st power, which is the same as 1/4. So for the end of the assignment, this chart is going to be very helpful. So if you don't have it, I would make sure to write it down. I'm actually going to erase some of this so that it but you can find the chart in the copy of the notes as well. All right.